All right, we are going to go ahead and get started. Thank you for joining us. We are excited to launch the first webinar of our 2025 webinar series. Today, we are talking about solar batteries simplified, where we'll have an emphasis on operating modes, money, and more. So let's look at the agenda and jump right into what we're going to be talking about today. My name is Mark Lennox. I am the Senior Manager for Product Education and the host of our webinar series. We are incredibly grateful to have another year of this series, and we're excited to show you and talk to you about batteries, an incredibly important topic. So let's get into it. So first, we're going to start with best practices and setting the right expectations. We'll go pretty deep there. And then we're going to talk about the key differences between the batteries that we offer between SolarEdge, Enphase, and Tesla. We'll talk about the different operating modes in Aurora and what are the best practices for the backup modes and non-backup modes. Then we'll talk about how the different battery offerings impact the TPO products in Aurora. And then, like all of these webinars that we do, we will wrap up with a Q&A session. So if this is your first time attending one of these webinars, about halfway through, you will see a box appear on your screen, and that's an opportunity for you to start submitting questions throughout the presentation. After the presentation is complete, we will jump over to a live Q&A session. We've got key stakeholders here from our electrical teams and the usual suspects here to help us answer your questions and address things you may have heard in this presentation about batteries. So, setting the expectations. We see this as one of the key things that we have to emphasize in this webinar because of the amount of questions we get about batteries in general, not just from the reps in the field, but from homeowners, especially on install day. So, battery projects are complex in nature, and providing backup to the home is a process that needs to be discussed in detail with the homeowner. Setting the expectation for what loads can be managed, for how long those loads can be managed, it really depends on the amount of batteries that are added to the project, and that's a crucial step in preventing issues down the road throughout the project all the way up into install. So we're going to talk in detail about what expectations you can set, the information you can study as a part of the sales team to really maximize the benefit and help with customer understanding about what they're getting. So the first thing we'll start off with is if you're offering some sort of whole home backup, at a minimum, 2 batteries are typically going to be required. And the larger the energy profile, the more batteries that are going to be needed for that solution. And the term whole home backup is an industry term, but you need to set the expectation with the homeowner that yes, there is potential that all of the loads in your home could be connected to backup, but that doesn't mean that it's power in perpetuity. There are limitations depending on what appliances and what loads are backed up for how long those things can be backed up. And using the tools that we've provided inside of the Sales Resource Center, inside of our Lightspeed, across the board, and inside of Aurora will help you set that expectation with the homeowner so they understand really what they're getting. Now, when you look at the adder sheet, you're going to notice that the first battery has a higher cost. And the reason why that is different from the second and any additional battery is because that first battery includes the controller and most of the electrical work costs. And that's what's built into that first battery cost. Anything beyond that first battery has minimal labor and minimal material costs. So it really is just paying for the battery itself. Now, because of the additional components, backup projects can take longer to install than non-backup projects. And we're going to talk about the key differences, obviously, between the difference between backup and non-backup. We can just get the cat out of the bag here. Backup prevents the home from losing power for a set amount of time in the event of an outage. Non-backup batteries do not do that. So they are far less complex. Now, right now, SolarEdge batteries are about 80 to 90% of our current battery volume. There are Tesla Powerwall 3 inventory issues across the entire industry. Now, ideally, those issues would be resolved by Q2, but there is no guarantee. So we will emphasize the Solar Edge batteries in this presentation and talk about them a lot, because those are going to be the things that are most commonly pitched to customers until any inventory issues are resolved. So when you're talking about the differences between the batteries, we're going to break that down in detail later in this presentation. So what are some of the challenges with existing practices when pitching batteries? We've talked to our operations team and we've talked to sales teams, and typically the number one issue that we see is customers are not informed about the system limitations, i.e. the duration of the backup. So for instance, if a customer is expecting a whole home backup, but there's only one Solar Edge energy battery attached, the expectation has not been set, and sometimes when our install crews get there, the expectation of what the battery can do versus what it's going to do are vastly different, and it causes issues we call code reds. So we see sales reps over-promising on the capabilities, leading to post-installation dissatisfaction. Again, customers believing that just one battery is going to back up the entire home. Then there's a misalignment between sales quotes and the actual system configurations. So when we see these issues pop up, and we'll emphasize this pretty often throughout this presentation, is that an install crew is going to show up to install the battery based on the specifications that were chosen on the project generation screen when the sales rep is picking which loads are going to be backed up with the customer. An install crew will not tell a customer that a battery can do something it cannot. They're going to go by the codes, and they're going to go by what the battery is capable of. So again, it is up to the sales representative to inform the customer what they're getting, what it backs up based on their preferences, and what to expect on the day of install. Our installation crews are going to meet with the homeowner, choose the location of the equipment that's being installed, and then have components that say, this is the portion of the home that is backed up, and this is the portion of the home that is not backed up. Typically, where we're seeing a lot of issues in the field is that the homeowner is shocked or surprised that not everything is being backed up by this one battery. So again, we are encouraging everyone to get as knowledgeable and informed on what the batteries can do, what tools you have available to you, so that these issues do not pop up and that things get delayed or just, go to that code red situation on install day. So with all that being said, let's talk about best practices for discussing batteries with your homeowners. We suggest that starting at the storage guide on Lightspeed is the best way to plan out the number of batteries a customer might need based on what they want to back up. So the storage guide itself is a great option. We'll talk about it in an upcoming slide. Based on the information that you've received from the customer, determine if the best course of action is a backup or a non-backup scenario if the customer is operating in a utility with export rates. In many situations, if the customer is most concerned about savings, a non-backup battery provides more savings at a reduced cost. And you can see those differences on the adder sheet on the price differences between a backup battery and a non-backup battery. So it's important to discuss what the battery options are, what their capacity and output are, and how many they would need depending on the loads they want to back up. And again, we'll talk about this and we'll demonstrate it live, but make sure that the corresponding inverter matches the battery type. So when you're on the design page in Aurora, choosing the Tesla inverter for a Tesla project, the Solar Edge inverter for a Solar Edge battery project, or the Enphase inverter for an Enphase battery project. The one thing we will also make note of, especially in states like California, Illinois, across the board, make sure that you have chosen the correct post-utility rates for the market that you're operating in. So like in a state like Illinois, or many of the other states with our TPO partners, we have a TPO rate guide that gives you the correct path to take for pre and post-solar rates. Especially when you're going to be discussing savings with the homeowner, choosing those post-solar rates is essential to demonstrating the correct savings in backup and non-backup modes. So if you haven't had a chance to take a look at the TPO rate guide or the products at a glance document that's in the Sales Resource Center in our Finance and Payment Options folder, we highly suggest you grab a hold of those, download those to your devices. They are full of essential key information beyond what we're discussing today, but has key information about batteries and utility rates. So this is the example of the Lightspeed storage guide. Again, we're going to use this tool to assist the homeowner in planning items in the home that would be backed up with their storage. The more circuits chosen on this screen will determine how many batteries are needed. You can see that we have different battery options, and it goes by state-by-state basis as well. If you use this tool coupled with the battery planning tool and the project generator, this should give the homeowner clear guidance as to what will be backed up and, more importantly, what won't be backed up. So again, we're keyed in on setting the expectation. There will be some updates to the storage guide coming in the near future. They're not ready yet, but this page will see some improvements. And we're also going to show you what it looks like on that project generator screen, what safeguards are put in place in Lightspeed so that when you are choosing what loads are going to be backed up with the homeowner, it will tell you if you've chosen enough batteries in Aurora. So multiple ways to get there. This is the first step, the initial step when you're planning the project, and then making sure that whatever you've done here, you choose as well on the project generator as you're moving this project back into Lightspeed. Now, an additional resource that you're going to use when you're planning a battery project in Aurora, which is also an incredibly informative page, is the storage page in Aurora. So this page shows the different battery operating modes, the different batteries themselves, how to choose quantity, and with SolarEdge, you'll choose the inverter that goes with that battery. So you can see from the example screenshot here, I've chosen the SolarEdge Energy Bank for backup in California. I've got the quantity set at 2, and my operating mode is backup. So you'll see the capacity on the lower left-hand side and the output for 2 of those batteries and the cost for those 2 batteries. And then on the right, you'll see if you're backing up essential outlets with this quantity of batteries, it's going to back up that home typically approximately 7+ days, appliances 7+ days, and because of the system size, and I think in this example, it's a 4.51 kilowatt system, that with those 2 batteries, it's going to be able to back up whole home for 1.3 days, estimated by Aurora. Now, the larger the system, the larger the energy profile for the home, these numbers will be impacted. If they're heavy users and you have 2 batteries, the essentials, appliances, and that whole home concept could be much lower. If you were to switch these to the end phase batteries, you'll see that. And when we jump over to the live demonstration of this, I'll show you what that looks like. Now, you can also use this page to demonstrate backup and the self-consumption non-backup mode. It is important that when you're here, you choose the non-backup battery. So when you choose the operating mode, you're showing them a non-backup battery, especially if you're using SolarEdge. Choosing the correct battery is essential for demonstration. So now let's look at that last page in the project generator where you are choosing with your homeowner what's going to be backed up and some of the error screens that could pop up if you choose too many boxes and you haven't selected enough batteries. Okay, so this is what the project generator storage page looks like. And again, this is one of the final steps when you're at PG, when you're doing the battery process with the homeowner, choosing which loads you're going to back up. You'll notice that the screenshot that I've chosen here has a resolution requirement. So you'll see in that bright red line, resolution requirement. Based on your storage guide selections, this project now includes 3 batteries. In Aurora, you charge the customer for 2 batteries. So then it's going to give you some options for resolution. You can go back to the storage guide and adjust the loads to bring it down to 2 batteries, which is, in this situation, what the customer was pitched on. We're going to attach 2 batteries. You can move forward with 3 batteries, but it will impact the net PPW of that project because that 3rd battery there's a cost for that. Or you can return to Aurora and adjust the battery sold quantity and the gross contract amount. So if you've already sent the loan docs, you'll need to submit a new loan application. This is put in place to make sure that quantity and loads match up and that expectations are being set. So the more time you spend here with the homeowner, making sure they are aware of what's being backed up, it saves our install crew and everyone along the line on this project so much time and effort. So please do not fly right by this page. Make sure this is planned out with the homeowner. Take advantage of it. It is a vital step for storage projects. So let's talk about some additional recommendations for sales teams. Right now, because of the supply issues, it's important to emphasize SolarEdge over Tesla in marketing and customer discussions. We don't know when those issues with inventory will be discussed, and again, about 80 to 90% of all of our battery volume anticipates to be SolarEdge until they're resolved. Prioritize non-backup configurations where possible for a couple of reasons. It's an easier installation, therefore requiring lower reliance on battery-trained install crews. So if it's a situation where the customer is heavily emphasized on savings, they are in an export utility rate, then a non-backup configuration might be the fastest, most path of least resistance for that homeowner. But it's also important that you ensure customers understand the difference between whole home and partial home backup. Again, you're probably getting sick of me saying setting the right expectation, but it's important that they know what's going to be backed up. And if you're wondering which utilities are capable for that self-consumption, non-backup battery option, we have an export utilities guide in the Sales Resource Center, so you'll be able to see where and which utilities you can offer non-backup batteries. With that being said, let's get over to the key differences between the batteries. So we will start at the SolarEdge Energy Bank. Obviously, we've talked about it's pairable with SolarEdge inverters, available for backup and non-backup. You will see that option in the drop-down when you're on the storage page in Aurora. No supply shortages there. The battery size is 9.7 kilowatts. It has a 5 kilowatt output. And again, it typically takes 2 SolarEdge batteries to provide decent loads for backup. This battery is DC coupled, meaning no energy loss during conversion. The Enphase IQ5 battery is a smaller battery option that is stackable. This is probably our lowest volume battery. It can be used in backup and non-backup. This battery, though, is perfect for a situation where only small loads need to be backed up. It's kind of an ideal option for smaller systems. It's the least expensive option and must be coupled with Enphase inverters. The Tesla Powerwall 3 is typically used for home backup. The Powerwall 3 has an integrated inverter. Now there is the stackable versions of the Powerwall 3 where this first Powerwall 3 has the built-in inverter, and then the Powerwall 3 Plus batteries, those are stacked and don't have the inverter built in. The inverter that's built into the Powerwall 3 typically can handle the vast majority of loads. The battery size for the Tesla Powerwall 3 is 13.5 kilowatts and has continuous power at 11.5. Price varies by state, and again, we emphasize that supply shortages will extend timelines on battery projects for Tesla Powerwall across the industry. It's not just something that's impacting us, this is industry-wide. So let's talk about additional costs and timelines for backup battery situations. Backup battery projects have additional items that can impact the cost of that first battery. Again, we talked about it before. The reason why that first battery is more expensive than additional batteries is the extra components necessary to install that project. And backup projects require a crew specifically trained to install the battery so that the loads are being backed up and that's installed properly. You should let customers know that install times are AHJ dependent and crew specific. So if they're needing something faster and they are, more concerned about savings for complex utility rates and export rates, if it's an export utility, a non-backup battery option is a great option there as well. We do want to point out that if you go to the Sales Resource Center to our document library, inside the equipment collateral folder, there is extensive documentation about how each of these batteries work, the spec sheets, and everything that you would want to know about whether it's the SolarEdge Energy Bank, the Enphase batteries, or the Powerwall 3. There are resources in there that we provide to you so that you can grab the knowledge necessary to discuss these batteries with your customers. So again, that's in the Sales Resource Center in our document library under the Equipment Collateral folder. So let's go over some key reminders again. Every AHJ is different. Install times and permitting can be impacted by adding batteries to a solar project. Depending on the product chosen, the additional load may require an MPU, so keep an eye out for that. There could require change orders if an MPU is triggered for a battery project. Any kind of work that requires additional subcontracting will extend install times. Make sure you're informing the homeowner of that with these battery projects, they can be complex, so the timelines may be extended. Projects that include a non-backup battery install much faster, as the all install crews can handle those installs. Use the storage guide and help homeowners understand what their batteries are able to back up and what they're not able to back up. And again, we reiterate, an install crew will not tell a customer that a battery can do something it cannot, which leads us to kind of that key point about code red jobs. A code red job is considered code red when the install crew shows up to complete the job and cannot due to the customer declining. And we want to reiterate that typically this happens when the expectations are not set ahead of time. The customer thinks they're getting something they're not, or they believe the solo battery that's been sold to them is able to back up their entire home. So most times, battery projects that code red are due to improper expectations being set. And we have operations folks on here to answer questions because we want to make sure that everyone understands we want to avoid these things at all cost. We're trying to educate the homeowner and our sales teams on how to avoid projects where trucks roll out and the project's going to be installed from, like, when they don't get installed. That's a huge miss. So now we're going to talk about the different operating modes in Aurora in a live demonstration format. So let's hop over to Lightspeed and Aurora and take a look at how those work before we wrap up with the differences between how these work in the TPO products. Okay, so we jumped over to Aurora and we are past the design mode. So I've already entered in the utility rates. This is a demonstration project in California, and I've already placed panels on the roof. So from default, we're going to go through this process. There's some best practices here that should be followed when choosing the right options in Aurora on the storage screen. But first, we need to make sure that we've chosen the right inverter that corresponds with the battery. Again, you can see I've already designed the system for this demo project, and we're going to go with the SolarEdge battery. So I'm going to choose the inverter button here and make sure that my SolarEdge inverter is there. It defaults to that because, again, it represents about 80% of the current volume. So from here, I'm going to click on the storage page. And you can choose the SolarEdge battery from the drop-down. I've chosen this SolarEdge backup for California. And I've increased the quantity to 2. So again, you'll see the capacity, output, cost. And from here on this screen, you'll see that for essentials, appliances, and whole home, we're backed up for 7+ days, 7+ days, and 1.3. If I were to reduce this down to 1 battery, you'll see how it changes based on that usage profile of the homeowner. And then the corresponding price, output, and capacity changes as well. Now, again, this isn't the North Star here. It's used, again, to demonstrate how many batteries are needed. So this page and the storage guide should be used with homeowners to determine the amount of batteries needed. There is a heavy emphasis on expectation setting for this webinar, and for good reason. The work you do here will prevent you from having to fix issues or potentially lose projects down the road. So I'm going to go back over to the design screen now and change my inverter to end phase. From there, you'll have to click the recalculate button. Now that that's wrapped up, we'll go back over to the storage page, and I'm going to choose the end phase batteries for California. And you'll see the output and capacity is way different. So you'll see how that impacts here. Now, I'm going to go back to Solar Edge now, and I'm going to choose non-backup for California. I'm going to leave that at 1 battery, and I'm going to change this to my inverter. I've chosen my non-backup battery here. Now I need to change my operating mode to self-consumption. So we're operating right now as if this is an export utility rate. And you're going to see right now what the average monthly bill would be in a solar-only environment, and then what, based on this one Solar Edge non-backup battery, what solar plus battery, what their average monthly payment would be here. Now, one of the key things I want to point out on this page is that this number and this, essentially both numbers, are grid usage and fixed cost combined to give an average here. So you can see that, you know, for solar only in this project in California, for many months out of the year, we're going to average over $100 bill still on the utility. To add that non-backup battery would reduce the bill to $37.36. If I hover over each month, it's going to say like what the average bill would be for that month. And you can see that certain months out of the year, March, April, May, that solar plus battery costs are $16.17. How this impacts your customer is to demonstrate the savings and the importance of adding a non-backup battery in an export utility. So now that we have those numbers of what their solar only versus what their solar plus non-backup battery would look like from a savings perspective, you can use this backup reserve slider to drag this to the left and right to see how it's impacted by keeping some of the reserve there. When we get to the TPO discussion, we will talk about how different products, if you adjust this slider at all, it does make it change to a backup situation. So if you are using non-backup batteries, leave this backup reserve at 0. So I'm going to press the done button on the upper right hand side just to show you what this means together. So I'm on the pre and post solar page to demonstrate what you're saving the homeowner. I've chosen my product. In this example, we are using an EnFin PPA. And remember, when we were on the storage screen, we had a combined average of $37.36. On this post-solar page, these two numbers, the remaining grid costs on average and the fixed costs, are combined to create the monthly remaining average if they use a non-backup battery. So in this scenario, with the product I've chosen and the remaining grid and fixed costs, we're saving this homeowner about $70 a month, right? So increasing or removing the non-backup battery, you'll see how that impacts the customer's remaining bill in a non-backup export rate situation. So while we're here, let's now move into the discussion about the TPO products and what they mean. Specifically, let's talk about that slider. So in a good leap situation, when you are using a non-backup battery, it is important to leave this at 0. For good leap specifically, changing this backup reserve, that does trigger it to then return to a backup battery because there's some sort of backup reserve. So it's important that depending on what you're going with for the homeowner, you can demonstrate savings here by changing the operating mode, but you have to make sure that you're choosing the right operating mode when you then submit the project. So if it is a backup project, make sure you're choosing a backup battery. and leaving the operating mode in backup. In non-backup situations, make sure you have self-consumption. This will impact the different savings requirement tests for each utility. And we have a great video that Rob Angel made that really goes in deep into discussion about how the savings tests work for TPO partners. So we're not going to belabor too much of that in this webinar. But as far as battery operating modes go, choosing the correct battery and the correct operating mode does determine the different EPCs and saving test requirements that come back when you're operating with TPO partners. So we will link to that video. You'll get a much better idea of how to properly set up your projects in TPO markets when you're choosing the different operating modes with batteries. All right. We have reached that time in the presentation where we are going to address Q&A questions that we've received throughout the webinar. So hopefully you've had some time to submit those questions. We're going to jump over to our panel of guests now to start answering all your battery related questions. And we will get to that now. And already we have seen some great questions come in to the Q&A. So our first question is from Brian, and we're going to send this over to Matt. Why does the inverter need to be the same as the battery? Matt, you got an answer for that one?
Sure. Yeah, this has changed slightly. Historically, the SolarEdge and Enphase batteries have both been only compatible with their inverters, but the Tesla Powerwall 2, which was AC coupled, was compatible with one of those inverters. Since Tesla has shifted to the Powerwall 3, they are now DC coupled. So that means that the solar is going to be connected directly to that Powerwall 3 battery. So now all three battery types need to be associated only with their inverters. There is some small exceptions there with the Powerwall 3 can have some existing solar AC coupled, but generally speaking, Enphase, SolarEdge, and Tesla all will need to be paired with their own inverters moving forward.
Appreciate that. And Matt, I do apologize in advance. We're probably going to keep you pretty busy on this webinar with the questions. So this next question is also from Brian. It is, do you need one inverter per battery?
Sure. Obviously microinverters are a little bit different. Each of the batteries has a kind of a relationship depending on what mode it's in. Let's talk about SolarEdge actually. SolarEdge, for each inverter, you can have up to 3 SolarEdge batteries connected to that inverter. So it's not a one-to-one relationship there. You can have multiple inverters with multiple batteries connected to each inverter. Like I said, between 1 and up to 3 batteries connected to each inverter. With the Tesla Powerwall 3, you will typically only need, as Mark said in the presentation, only the one inverter with the main Powerwall 3, and each of the additional Powerwall 3s can be expansion units. So again, there's also not a one-to-one requirement there.
Appreciate that, Matt. We'll get that one off screen. So this next question is from Travis. They said, then this one's going to be for Rob. I have several clients in Arizona, including my own home, that have 1 to 2 Powerwall 3 batteries, but they don't export energy during the peak hours. Why doesn't it export power at the most critical time?
Yeah, hey guys, morning. And I'll probably tap in Markham on this one as well. I mean, the kind of settings and the profile that's used to determine when battery exports can be changed. Matt, maybe you can describe the best way to do that on the Tesla, but the homeowner is able to change kind of how the battery operates. It usually is a feature, or it's more actually setting the inverter and kind of telling it how to treat the battery, when to charge it versus when to discharge it. But that can be changed. So if you want changes, that can be done post install. Matt, correct me if I'm wrong. I think SolarEdge, they need to tell us, but Tesla, they can do it themselves. Can you clarify that?
You're right, and SolarEdge a while back has now released that different modes are available in their customer-facing app. So each of the battery manufacturers can leverage each of the settings in the customer-facing app, provided that the system is installed in the correct configuration. Like a non-backup battery could not be configured in backup mode in the customer app. And actually, I'm just going to go ahead and jump into the next question, because a backup battery can be used in self-consumption, or some would say energy arbitrage, or in a mode where they're discharging for the best savings. So backup batteries can do both, depending on how much backup reserve you have. That could affect the amount of energy that they have reserved for backup. But non-backup batteries will only have the self-consumption or the kind of arbitrage modes available to them, all in the customer-facing app.
All right, appreciate that. We'll get that one squared away, and we'll archive that second one you answered. Okay. This next question is from Chase. Is it true that the SolarEdge batteries output are determined by the size of the inverter installed with the system? We've been told that a 5 kW system will require 3 to 4 SolarEdge batteries for full backup, but a 12 kW system only needs 2. I'm sure that's for you, Matt. Can you provide clarity there?
Yeah, that sounds like a little bit of a misunderstanding or misconception, or bad information. Essentially, as I mentioned, the SolarEdge battery, SolarEdge inverter can have up to 3 batteries behind it. The output rating of each of the SolarEdge inverters is up to 11.4 kilowatts. Each battery can discharge 5 kilowatts. So you could have an 11.4 kilowatt inverter output and have 2 batteries, and you could have up to 10 kilowatt output coming from the batteries, and you could have the additional 1.4 kilowatts coming from the solar. That could also be true if you only had 1 battery and 5,000 or 5 kilowatts were coming from the battery, and potentially if you had a larger PV system, the additional 6.4 kilowatts could be coming from the PV itself. So it's limited. Your output's going to be limited by the inverter output, but depending on how many batteries you have, the solar can be additive to the output of the batteries up to that maximum output of the inverter.
Let me try. I think that's an important one. Let me try saying that in slightly different words, Matt. And tell me, maybe this is more posing it to you, and you tell me if I'm right here. But there's 2 limitations on a backup battery system. Number one is the battery output, as you mentioned. With SolarEdge, that is 5 kilowatts, correct?
Yes, that's right.
And then you also have the inverter limitation as well. Almost always, pretty much always, Matt, tell me if there's a scenario where you wouldn't agree with this. The inverter output will be larger than the battery output. Would you agree with that?
The inverter output is the limiting factor for both the battery and the solar. So they're both DC coupled behind that inverter. So the maximum output of the combined battery and solar is going to be that 11.4. Where that energy is coming could be variable depending on how much solar you have or how many batteries you have, if that makes sense.
Yeah, I think the point I'm trying to make is that if we're talking at night and the power goes out, even
Right.
though you have, in this example, 11.4 total, you're only going to get it, and you only have one battery. You're only going to get 5, right? Because the
5,000.
battery can only pass 5, right? So depending on the situation, if you have, depending on the batteries and if the solar's shining, or, the solar's working or not, the sun is shining rather, uh, you're going to be limited to typically the inverter output up to the battery output, right? So if it's at night, you only have the battery, you'll typically be limited by the 5 kilowatt output of the battery. Whereas if you have, in Matt's example, an 11.4 and the solar system's working, you could go all the way up to that 11.4. You might have some coming from the solar, you might have some coming from the battery, but hopefully that probably didn't clarify it, but there's a little bit different way to say that. There's 2 limitations there: one on the battery, one on the inverter.
Appreciate that, guys. We're going to hide that one and go on to the next one. This is from Hannah. Can solar edge batteries be installed outside of the home, or do they require to be indoors?
Yep, I can go ahead and take that. So solar edge batteries are absolutely rated to be installed outdoors. The low temperature limitation is what we run into most frequently, which is 14 degrees Fahrenheit operating temperature. But an important thing to keep in mind is that is the operating temperature of the cells themselves, not necessarily the ambient temperature outside. So um, at or below that temperature threshold in order for the battery to not operate in that. I think that we'll see three does have a -4 degrees Fahrenheit operating temperature, and I expect kind of the next generation of Solar Edge and other batteries to be getting down to those thresholds as we see more batteries installed outside due to safety codes and limitations with that.
Thanks, Matt. This next question is from Mike. Will a solar edge in non-backup but with a 25% reserve provide power during rolling blackouts or any kind of outage?
Yeah, we're getting a bunch of different questions on kind of the difference between backup and non-backup and the capabilities of non-backup. So I think this is a good chance to probably answer several of those questions at the same time. So to be extremely clear here, a non-backup battery does not have the equipment necessary to provide power in the event of a grid outage. I'll say that again. A non-backup battery does not have the equipment necessary to provide power in the event of a grid outage. So if you have a non-backup battery and the grid goes out, so does your battery, so does your solar system. The homeowner will not have power. That is why those batteries are less expensive, and that is why the installation is simpler. It's because there's less to do, right? So that's a very key point that you all need to know. I will say that is on you to understand and explain properly to your homeowners. If we get issues with customers that don't understand that concept, that falls squarely on the sales rep's shoulders. We do have disclosure forms that explain a lot of this when a homeowner does sign up with a backup or non-backup battery, or it's in the language of the PPA or lease agreement. But that is a key piece to understand. I'm seeing other questions in here. One, for example, what is the difference between backup and self-consumption? That is the difference, right? Self-consumption only charges and discharges daily, does not reserve any for backup because it doesn't have the equipment necessary to provide backup power. Whereas a backup battery can provide backup power in the event of a grid outage, and it also, if it is set this way, can cycle daily. So if you are in a utility or in a state similar to California where there is a reason that you would want to store and discharge power daily to maximize savings and to avoid buying power at peak rates, you can do that on a backup battery. And you can also reserve, as this question asks, a certain percentage in the case where the grid goes down and the homeowner wants to make sure they have a certain percentage of reserve in that backup battery. Okay, so hopefully that answers your question, Mark. Feel free to Matt, if you want to clarify any of that, add some additional questions in here. But those are some key points to know.
Thanks, Rob.
And sorry, just one last thing. If you are trying to, you alluded to this in the webinar, Mark. If you are trying to sell a non-backup battery, your backup reserve should always be 0. You should never have a non-backup. If you're trying to sell a non-backup battery, you should never have the backup reserve set to more than 0. All right. And in the case of certain TPOs, specifically GoodLeap, if you do have it set more than 0, they will recognize that as a backup battery. They will think you're trying to sell a backup battery, even though you might have selected a non-backup battery. All right. So I'll say it again. If you want a non-backup battery, you should put it in self-consumption mode in Aurora, and your backup reserve should be 0. It should never be more than 0. Next one.
Thanks, Rob. This question is probably going to be for you as well, Rob, and it's from Stanley. I have NEM2 clients who want to add a battery. Is that possible? I have NEM3 clients that would like to add a second shift battery. If no to either or both, when will we be able to sell batteries only?
Yeah, so a couple different questions that you may be asking here. So we do, first of all, Freedom does do battery only add-ons, but only for originally Freedom installed customers. All right. There are also some kind of financing implications there. I'm not going to get into necessarily all the details there, but there could be some implications of adding a battery if, like, you're on a lease, like if you have a PPA or a lease agreement there. So there could be some complications there, but generally, Freedom would install a battery only if it were a Freedom installed system originally. Now, in terms of how that kind of impacts NEM, if you're only adding a battery, it shouldn't impact NEM at all. And keep me honest here, guys, for anybody who knows anything different than I do. If you're adding a battery and PV system to an existing NEM2 or NEM1 system, as of this point, that would push both systems to NEM3. All right, I'm sure we're going to get some questions around retaining, NEM1 or NEM2. Not going to get into that with this answer, at least. But if you did add a PV and battery system to a NEM2, it would currently move the whole system to NEM3. If you have part 2 of that question, I have NEM3 clients that would like to add a second shift battery. I think we can do that. Matt, maybe you can answer that from a technical perspective. I don't know that we necessarily have that. Like, we don't see that often. I think we could, though.
For adding additional batteries to a NEM3 client?
Well, adding a second non-backup battery, like, I guess there would be issues with the financiers typically. I mean, technically, I think it would be possible, right? And it wouldn't impact, obviously, NEM3. They just want to basically add another non-backup battery.
Yeah.
So technically it's possible, but there's probably more to it than just technical installation. Yeah. All right. And then number 3 to that, if no to either both, when will, okay, so I already answered that. So sorry.
No, my bad. Didn't mean to cut you off. The next question is from Mike. Can you have one non-backup battery and a backup battery? Can you have multiple types, Matt?
Sure. Well, I guess it depends.
Let's just call that one a no, Matt.
Yeah, generally speaking, if you're selling a new system and you're selling backup, then it would not be ideal to configure one in non-backup and one in backup, because if you configure them both in backup, you can use the operational modes to have all the benefits of non-backup with the backup. If for some reason there was an existing system, both things could exist on site, but generally speaking, to Rob's point, no, that wouldn't be practical. You would want to put them both in backup and leverage the operation modes.
All right. This next question is about something that was in the presentation. If the offset is 100%, why is there still $100 from the utility company with solar? So, Rob, I'll kick this one over to you. This was for a California project with export rates.
Yeah, so there's actually like a couple different ways to answer this question. I think the question you're really asking is like, why, if there's 100% offset, why is there still a remaining utility bill? I think is the core of it. And the reason that is because, again, the way that a California job would work, or really any utility in what we call export, I hope everybody knows what that means. But a lot of your remaining utility bill has to do with every single day, every single hour, how much you're using versus how much you're producing or you're discharging from your battery. Right. So just because it's 100% offset throughout the year, any given day or any given hour, you could be exporting energy and importing energy. And so when you export, let's look at California as an example. When you export energy, you're going to get paid something like, I'll just make up a number. Let's just say it's 7 cents per kilowatt hour on average. Whereas every time you import a kilowatt hour, you're going to pay something like 30 cents. So even though throughout the course of that given day, you might have been 100% offset, when you're importing and exporting power, that matters from a remaining utility bill standpoint. Okay, you could be exporting power, getting paid 7 cents, buying power, getting paid 30 cents. In that example, if you exported one and imported one, you would have a 23-cent remaining utility bill, 30 cents minus 7 cents in this example. So there's a lot of math there. I hope that explanation made sense. But again, it's not just how much power you're importing and exporting. It's when you're importing and exporting it throughout the day, throughout the really every minute of the day. The other, so I hope that answer makes sense. I just want to add in one little nugget in here as well, is that it's also very important in Aurora. Whenever you have a non-backup battery, one of the things I have seen from time to time is that sales reps leave off the inverter on that storage page, specifically if you're selling a solar edge battery. That is actually really critical to make sure you have an inverter selected on the storage page in Aurora. If you don't have an inverter there, it actually won't apply the utility bill savings because the system basically doesn't recognize the fact that it isn't working properly. Like the Aurora system needs an inverter there to account for everything properly. So if you have a non-backup battery, it's super important that you make sure to also select an inverter on that page to get the utility bill savings to properly model itself within Aurora. So I hope those answers made sense.
Thanks, Rob. I want to toss this out there to you all. We've got this question a bunch, so we just want to clear this out. What typically with a backup battery system triggers an MPU? What are the things that you most commonly see that trigger someone needing an MPU?
I'd say that's to me, yeah. There's lots of different reasons for MPUs. There's some just red flag panels that have to be changed out, or conditions of the service, or location of the system. But the one that's specifically triggered historically by batteries is a limitation of capacity, where the outputs exceed what's permitted by code to be connected to that service. That specific situation is something that is becoming less and less of a concern with energy management system, a component called PCS, power control systems, that allow you to monitor the load coming from the utility and modulate the output of the batteries or inverters so that they don't create a electrical situation, a hazardous situation. So that is something that's actively changing. All three of the major manufacturers have solutions for that. So ideally, in the moving forward, we will see fewer MPUs directly triggered by capacity of the existing electrical system and the new battery and inverter installation.
Thanks, Matt. I think we probably addressed this, but we're still getting a lot of questions about it in our Q&A. Why is there such a price difference between backup versus non-backup?
I'd love to iterate on what Rob already said. He was talking about the equipment that's required. Specifically, there's a requirement to isolate from the utility grid when you're in backup mode. So there's a large, expensive piece of equipment, has different names depending on the manufacturer, the Tesla backup switch or the SolarEdge backup interface, Enphase system controller. So that equipment typically is going to intercept your main service conductors, your main feeders, which is an expensive installation. And then also, there's a lot of labor associated with, depending on the existing service configuration, relocating loads into the backup circuit. So the backup costs not only have additional equipment, but also typically a considerable amount of additional labor associated with them. Whereas the non-backup typically tie in just like your standard PV only installation, and the batteries are connected to the inverters, kind of limiting the amount of labor and additional equipment required.
Thanks, Matt. This question from Kevin: can you install more than 3 SolarEdge batteries? Is there a limit to the amount that you can add to one system?
Yeah, there is a limit. So for backup, each backup interface can have up to 3 inverters, and each inverter can have up to 3 batteries. So on a single site, you can have up to 9 SolarEdge batteries behind 3 inverters.
Appreciate that. This next one is from Sammy. State of California house already has solar and is now building an ADU. Can a battery meet the Title 24 energy code requirement for solar on the ADU?
I think let's follow up with individual. And this is a little bit more
pretty complex one.
Individual ones. Yeah, let's make sure
right.
I follow the same.
We'll take that one offline. All right. So this one was from Dennis. I'm confused. If a battery is 10 kW, how is the output limited to 5 kW? Why isn't it 1-to-1?
The confusion there is the 10 is actually kWh, kilowatt hours. That is a measure of the capacity. The 5 kW is a measure of the actual output. So capacity is always measured in kWh, which also is similar to how you're charged on your utility bill. So the 10 kilowatt hour is the capacity, the amount of stored energy for the SolarEdge battery. Tesla is 13.5 kilowatt hours. Enphase is 5 kilowatt hours. That's the capacity, not the discharge rate, charge and discharge rate.
So I think just want to hammer that one home because that's a very, very essential concept that everybody here knows. I mean, for those of you who've been around solar for a while, this is a very well understood concept. But again, just to provide an example there, Matt, and I think the same can be said about a PV system as a battery system. But if you have a 10 kilowatt hour battery that is whose output is 5 kilowatts, that battery can run for 2 hours, right? Because you have 5 kilowatts running for 2 hours. That totals 5 times 2 is 10 kilowatt hours. All right. If you had that battery discharging 2 kilowatts on that same 10 kilowatt hour battery, that battery could run for 5 hours. All right, so pretty simple math there. So super important that this goes back to the concept Mark was talking about in the main presentation, is that how a homeowner uses the battery matters a lot, specifically when they're in backup mode. So even though a battery is quote unquote whole home, there's a couple things that matter there. It doesn't mean that they can power the entire home all at once indefinitely. In fact, it might only be able to power 50% of the house at once, and it might only last for 2 hours, 3 hours. So there are limitations there, and it is important for homeowners to understand that. And that is your job to make them understand. And I know not all of you understand all of the nuances in and out, but just the concept that, hey, I'm going to call this whole home, but it doesn't mean that you can power your entire home at once for as long as you want. It would be better for you to power only what you need when you need it for as long as you need it, and don't waste energy. That is how you're going to maximize your battery and your backup power in the event of a grid outage. So all of that is super important to explain. We've done the best we can with the battery, with the storage guide to help explain kind of, you know, what a battery could power. So that's why it's so critical that you select the correct loads, right? If you don't select the correct loads, and the homeowner gets upset, and then it ends up turning into a code red, and then it's this he said, she said of who explained it wrong. If you didn't select the correct loads and you didn't select whole home or partial home, and there are customer kind of expectation misses, not to be too harsh here, but that is squarely on your shoulders as the sales rep. These are things that are critical for you to understand when selling a battery, in terms of what they can back up, and for roughly how long they can back up, or at least what the limitations are. All right, so hopefully that made sense, but these are very critical concepts for you guys to understand when you're talking to homeowners.
Thanks, Rob. The next question is from Jill, and I can kind of quickly answer this one. Where specifically do I find the Lightspeed storage guide and export utility list? The storage guide is located on the sidebar, the same area where your projects, leads dashboard, sales resource center. So it's going to be there, labeled storage guide. The export utility list is in the sales resource center in the utility documents, and we're going to add that as part of the recap when we send this out today. So, we added some questions that in the chat also about, is this going to be recorded? Will we send this out? This will be added to our video library in Lightspeed, and we'll also get a recap out this evening with any additional documentation attached, additional resources, and you'll be able to access the recording, including this Q&A. So look for that, and we'll get that out to you. We are about 5 minutes past, but as long as the folks here on our panel can stay, just let us know when you guys have to jump. We'll keep powering through these questions. We have a good question here from Gunnar, and that is, how does the limiting factor of the SolarEdge inverter compare to the limiting factor of Enphase and Tesla? Since Enphase are microinverters, are they better for the customer to sell those inverters with 2 5 PS compared to 1 SolarEdge? I assume that's for you, Matt.
Yeah, I mean, I don't know exactly what you're asking on the limiting factor. If you're talking about power output, I believe the power output of the Enphase is 3.84 kilowatts compared to the 5. So 2 5Ps, the power output would be slightly higher than that of the SolarEdge, but they're also AC coupled batteries, which means that there's some additional inherent efficiency losses because you're converting from DC to AC and then back to DC and back to AC. So if you're using them for non-backup and self-consumption, they're going to be a little bit less efficient. There are other different factors, but I would think those would be the two most impactful ones.
Yeah, and I would say, maybe to add to that, I think in terms of straight output, I don't think it's any secret that Tesla is the best product. It's what, 11.5 continuous, Matt? Is that right?
That's right, 11.5. Yep.
11.5 compared to, if you're just talking the battery, basically 5 on the SolarEdge. That said, and this is where I think we've run into some issues recently, is if somebody's talking about a Tesla and they're expecting a whole home, and then somebody swaps to a SolarEdge, or people are used to selling Tesla and now they're selling SolarEdge, there is going to be a difference in output, or essentially what a homeowner could power between a Tesla and a SolarEdge. I think SolarEdge, without question, is the preferred product in a non-backup scenario. But on a backup scenario, it is going to depend on what the homeowner wants to power. And so, what I would say is, again, super critical that you use the storage guide properly and in good faith and in conversation with the homeowner about what they want to back up and what impact that will have to how many batteries they would need and what the cost of that system would be. I think most homeowners don't understand any of this, and they expect, hey, I have a battery, I can just power my whole house all the time. And it's, again, I'm beating a dead horse a little bit here, but it's your job to help explain the realities that, hey, listen, yes, you have a battery, but it's only going to produce a certain output, and it's only going to have so much storage capacity. So having that conversation is super important. This isn't to say that you should sell a Tesla anytime you want to go in backup. In fact, I don't think you should. But there are situations where that may make sense, or where otherwise makes sense to have 2 SolarEdge batteries. For a homeowner who needs 2 or 3 SolarEdge batteries, from a homeowner who needs to back up more items, and those items are larger demand items.
Thanks, Rob. Thanks, Matt. Question from Greg is: Can you add to a non-backup battery at a later time to make it backup? So after it's been installed as a non-backup and they decide they want it later, is that something that's possible, or is it like pretty set in stone?
I will say that it is possible, but if you think that there is that possibility, I would highly discourage you from going with the non-battery backup first, because there's a lot of rework that would need to happen. Now, a non-backup battery, you could add additional non-backup batteries to that system very easily, because they're just connecting straight to the inverter. But as soon as you go from non-backup to the backup, you run into all of those complications that I described with that microgrid interruption device, as well as the load relocations, and the equipment's going to have to probably be removed and relocated. So it's not a simple transition at all.
Appreciate that. So we get a question about inverters and inverter selection. There are so many different types of SolarEdge inverters. How do we properly pair those with the SolarEdge battery?
So the SolarEdge battery.
Let me take this one, Matt. Yeah, let me take this one, because I think this is more of a Aurora kind of proper setup question. Little bit of nuance here, so I apologize in advance, but there's 2 places that you're gonna in Aurora that you're gonna select an inverter, and they're actually at this point in time, very disconnected. One place is when you're designing the system. You have a button that you can press where you choose the inverter manufacturer. So you're going to select from either Tesla, SolarEdge, or Enphase. Important there. The only thing that you need to know is, like, if you're selling a battery, match the inverter to the battery manufacturer. And so if you're selling a Tesla, select a Tesla battery. If you're selling a SolarEdge, if you're selling a Tesla battery, select a Tesla inverter. If you're selling a SolarEdge battery, select a SolarEdge inverter on that design page where you're designing the system. On the storage page, I think that's what you're asking here in this question, is which battery do I choose on the storage page? It matters less on that page. I would say if you're selling a SolarEdge battery, my recommendation, Matt, keep me honest here, is I would say match the inverter quantity to the battery quantity and choose the 7600 inverter. And that's really that will make sure that there's no changes to savings or changes to output or production on the system. As far as Aurora is aware, I understand, Matt, from your perspective, technically that's probably not the way it's going to be built, but in Aurora, that will make sure that there's no adverse action to your system with those settings. So match your battery quantity with your inverter quantity and choose 7600s. Would you agree with that, Matt? Or is that good enough for you? I guess I would say.
Yeah, I'm not. I'm glad you took that, because I'm not super familiar with the configurations in Aurora. I would say the full suite of home hub inverters are what we pair with the SolarEdge batteries, but I don't want to. So like the 3.8, the new 5.7, the 7.6, 10 and 11.4, they all have the same 11.4 output. But for simplicity, I would defer to your recommendation on how to select that.
Sorry, a little mic issue there, y'all. So a lot of these we're getting are duplicates, and we want to make sure that we're respecting everyone's time. We're about 15 over. Matt, were you able to address any questions about the Tesla expansion batteries, availability, and how those work?
Yeah, sure. Yeah, fundamentally with the Powerwall 3, what they did in going to a DC coupled system is they built a very robust inverter that is actually selectable. It's a single inverter, but it's selectable output, and made sure that the power output capabilities were such that you didn't need to add additional inverters. So that single inverter can do up to 20 kilowatt DC of solar connected to it, and the output is such that typically you can handle any home loads with the output. So any additional units that are ordered would be fulfilled with the Powerwall 3 expansion units, which is the same battery essentially, but I think it was touched on earlier. It just doesn't have the inverter in it. So same battery, same capabilities, just doesn't have unnecessary components.
And Matt, we would typically make the decision on whether to use 2 Powerwall 3s with 2 inverters or Powerwall 3 with an expansion based on what the homeowner's trying to back up and what the solar looks like and all that. Is that right?
Yeah, there are a few instances if you have larger than 20 kilowatt DC solar, we would automatically default to 2 Powerwall 3 kind of primary units, or if you were trying to split or back up a split 400 service or something like that, we may do that. But generally, for the average project, we're going to be installing the Powerwall 3 and Powerwall 3 expansion units connected directly to that.
I think it would be helpful, Matt and Mark, if we take a quick minute and give a kind of a live example and help people understand the output piece. I feel like the output part of batteries is the most misunderstood or less understood issue of all of this. So, Matt, if I could just ask really quickly, so let's pick 1 or 2 large appliances that a homeowner might have. So let's talk about a central AC system. If you have kind of an average AC system,
Yep.
what kind of demand would that be? Like, what's an average system? 3, 4 watts, something like that.
So an average AC, the running amps when it's just operating are going to be somewhere in the realm of about 16 amps to the low 20s amps. When it first starts up, the instantaneous demand to get that big fan started usually spikes just for an instant up to somewhere between 60 and 160 amps. And to convert amps to kilowatts, you would multiply by our nominal voltage in the United States is 240 volts. So inversely, I probably should go down this rabbit hole, but a 5 kW output divided by 240 volts is 20.8 amps. So if you're talking about a solar edge battery, just one air conditioner without all of your other lights and outlets and microwave and other essential loads is basically going to take the entire output capacity of that single solar edge battery, which is why we highly recommend that you use at least 2 for any kind of backup scenario. Let me just stop there for a second. Do you want me to keep going into additional scenarios or talk about Tesla inversely?
Matt, it's possible we just lost Rob, so if you want to just keep
Oh,
going.
well, yeah, I have a tendency of getting way too technical on these type of things. But let me tell you the biggest difference between SolarEdge and Tesla is that SolarEdge, the way that you configure the batteries behind them, they are additive. So they both have basically for 1 to 3 batteries, a single inverter and up to 3 batteries behind it. For SolarEdge, in order to get the full output of that inverter, you need 3 batteries or 2 to 3 batteries. Tesla, each battery is capable of outputting that full 11.5, which is let's see, which is actually almost 48 amps, which, like I said, could handle probably a much larger air conditioner as well as a number of other home loads. So there's a little bit of a difference in the power output, but hopefully I didn't just confuse everybody.
Yeah, thanks, Matt. Sorry, guys, I lost internet there for a minute. But yeah, I think you answered. You got down where I was trying to go. There is just the fact that you're going to have issues with larger loads, and yeah, and you're going to have issues running your entire house on a single battery, or in some cases 2 batteries, if you have larger loads, right? So I think you nailed the concept. So sorry about that.
All right, and so yeah, we've been hitting some technical difficulties. Looks like Mark's internet just went out as well. A lot of like Mark was